Hello, welcome to this video on exercise 6D where we look at the surface area of prisms and cylinders. To be clear, just want to point out that we're doing a surface area, or what is also abbreviated to TSA, total surface area. So surface area, if we think three-dimensionally, we're considering the area to cover the object. So if we were looking to wrap my pencil case, okay, how much wrapping material would I need? How much area of it would I need to cover this pencil case? So let's go on, and of course today we're looking at prisms and cylinders. So prisms are effectively three-dimensional rectangular shapes, so this would be pretty close approximation of it. Like, I have rounded corners, but we're close enough is good enough, so this could be approximated by that. And then cylinders, of course, would be like this candle. Now this is an open-ended candle, so not very good. Imagine that's closed. What's the total surface area? How much wrapping paper would I need to wrap that candle? Okay, so let's go back to PowerPoint. Cool. So starting off with this cylinder will lead us into, there's two methodologies that we can use when we're dealing with prism, cylinders, and then complex shapes. So complex shapes would be a combination. So if we had something really hard like this with a cylinder sitting on top of a prism, how would I find the total surface area of that? That's a complex shape. It's combining two basic shapes. We need to think about what are the individual two-dimensional faces. What are the faces? These are called, each surface, go back to my camera, this here, that is a surface. Okay, so we need to think, okay, what's the total area of that surface? Then in the other end, this is a surface, what's the total area of that? And then we have what I like to call a lot of time is the wrap. Whenever we have something that curves around, so in this cylinder, curves around, I call this the wrap. And we look at it, let's say starting at this sticker, okay, it goes all the way around, all the way around, all the way around, and we get back to the sticker. So that surface around. Now if we unwrap that, okay, say if I cut it straight down that sticker line, if I cut straight down there and unwrap, peel it out, what's that going to look like? Well, it's actually going to look like a rectangle in this case. We can sort of see there as that cylinder's been broken apart, it unwraps, and it ends up giving us, this is called a net, which is a shape unwrapped. Okay, we've got this net, ends up being two circles. Okay, so we've got a circle down there, we've got a circle there, and we also have a rectangle. And the key part of the cylinder and where this is going is we're building a formula that'll tell us the TSA, the total surface area of any cylinder, is this length here, is that length there. Okay, so that's why we have this arrow pointing to the wrap, and the length, we could effectively say this is our length of our rectangle, because the area of a rectangle is equal to length, width times length, not length. Area is width times length, so that is going to be width times, and in this case, the length is our circumference, so it's going to be 2 pi r for the area of the rectangle. Now, area of a circle is equal to pi r squared. And we have two circles and a rectangle. We can add all of that together to get a formula for the area, total surface area of a cylinder. Before we go any further and I tell you what that equation is, there is another method. Instead of building a formula for every type of shape, there's another method that is commonly used for complex shapes, and that's what we'll call method 1, which is breaking down the shape. As it says there, it's really useful for when we're dealing with composite shapes that might have faces missing or double up or there's overlap. The only negative point to this is it can be very time consuming and sometimes you can miss certain faces. The second method, which is much quicker, is applying the formula, and you should always try and use it where possible. Again, the risks to this though are missing information, the formula not being perfectly applicable, because this candle, if I said find the total surface area of this while saying it's open, well, my formula doesn't work anymore because it's missing that circle face off that end. So your formulas won't always work, so you can't always rely on them. As it says there, when finding the TSA of composite shapes, you could build one massive combo formula. It's like, okay, we'll take the formula of the cylinder on the top, okay, of the cylinder, we'll combine it with this prism, we'll then take away some certain bits to make it work. We can make a very long formula, but sometimes it's pretty easy to make mistakes doing that. So it's easy to do the breakdown and just look at individual faces. Just list all the faces is pretty much what method one is. List all faces and work on them individually and then just add them together at the end. Okay, so where I was going with all of this, the total surface area, a cylinder is made up of two circles and the wrap, which if we unfold the wrap is just a rectangle. And it turns out we have area of a circle times by 2, so we get pi r squared times by 2, and then we also have the area of the rectangle, which is length times width, which we showed was in this case, I just want to make sure we use convention as width times 2 pi r. So if we have two circles plus the wrap, the TSA is also equal to, got my slides. I'm showing how to make the formula for the next slide. We'll go with that. TSA is equal to two circles plus the wrap. It is equal to 2 times by pi r squared plus the wrap, which is width times by 2 pi r. So we get 2 pi r squared plus, and in this case we don't actually call this the width, we call it the height of the cylinder. So effectively how tall, because you can imagine the cylinder being like that, and that length there is exactly the same as that length there. So instead of W, we call it height. So we end up with 2 pi r h, and that's our equation. Shows where it comes from. Okay, but that shows where this formula comes from, and you literally substitute in, because all you have a pi, which we have on our calculator, r, which we know is 5 meters. We have a pi again, we have an r, which is still 5 meters, and then we have our h is equal to 25. So all it turns into, if you remember the formula, is you just got to substitute two numbers in. So that shows how method 2 can be very easy, because this formula always works for a regular cylinder. If I can type it, oh my god, cylinder. Now method 1, the breaking down the shape. Let's look at the individual faces. Get rid of all of that. Let's get some color going. So what do we have? Well, we have that circle there. We also have that circle there that we can't really see, but it exists there. So we have, let's call this circle 1, and we'll call that circle 2. And then we also have the wrap. That goes all the way around. So area of a circle, and sorry, we'll call the wrap 3. The area of the circle is really easy. Area of the circle is equal to pi r squared. So we have 2 of those, which is we've got here. So we've got the area times by 2. We substitute in. Okay, so the area of my 2 circles is 50 pi. So we have that. That is 1 plus 2 right there. The area. And we'll use this numbering system, numbers in circles, to label faces a lot. So circle on the left plus the circle on the right gives me an area of 50 pi. Now the area of the rectangle, which we said is just the wrap when we unfold it, is length times width, where our width times by 2 pi r. So we get 2 pi times 5 times 25 is 250 pi. So that's our 3. That's our wrap. So our total surface area is clearly 1 plus 2 plus 3. So it's 50 pi plus 250 pi, 300 pi, and that's exact. And then you can just put in your calculator to get your decimal place. So that's breaking it down. It's just label individual bits, find the area of each of the individual bits, and add together. So 1, label individual faces. 2 is find areas of individual faces. And then 3 is just add them together. So that's how we do method 1. Method 2, remember, I just cannot spell today. Remember formula, which they're all given in your textbook and in the notes. 2, substitute, and then 3 is solve. That's all it is. Gives us the exact same answers. So let's do a couple worked examples, and generally anything composite will be a bit of a blend. Find the total surface area of this composite solid. Correct to 2 decimal places. Okay. So let's add in the rest of the shape so we can see it, visualize it. Okay, there we go. That would be the rest of the shape, so we can visualize it. So what do we actually have? Well, we have a open box, I guess we could say. We have that, and then we also have the top part. Like that on top of it. So let's start with the open box, nice and easy. We have this front face, which we'll call 1, which is also identical to the back side. Okay. So area of 1 is equal to length times width, which is equal to 4 times by 6.5, which is equal to 4 times 6.5 is 26, I think. 4 times 5, yes, 26. Now we also have the sides of the box. So we've done the front, so now we're going to do this side here, which is, we'll call 2. And then there happens to be the exact same on the opposite side. So area of 2 is equal to length times width again, with just one of them. And now that's going to be, draw it, so we're finding that as 10.3, and that's 4. So 3 times by 4, that's going to be equal to 41.2, I think. 1.3 times by 4, yes, 41.2. We've also got, I'm just going to do some erasing, make it easier to see. We've also got the base. Okay, so we've got this base down here, which we'll call 3. Area of 10.3 is equal to length times width again, and that is, we have 10.3 and it has 6.5. 10.3 by 6.5. Now that I can't do in my head quickly. 10.3 by 6.5. 66.95. 66.95. Now we don't have any top, okay, because there's no top there because it's replaced by the half circle, so the half cylinder. Okay, so what do we have? Let me just make sure it's clear. We have, that's called 1, that's called 2, that's called 3, and 1 was the front bit there. That was 6.5 and 4. So we have 2 of them, we have 2 of them, but we only have 1 of the base. And then we have the whole top. Now the whole top, and I'll bring your attention over here, it doesn't have any bit underneath it, it's an open underneath, but that there is just half of a cylinder. Okay, it's perfectly half, it's just cut in half. So we could say the area of, and I'm just going to use C for cylinder even though it's half, but we know according to the formula that is equal to 2 pi r squared plus 2 pi RH, 2 pi RH. So we can substitute into that. We get 2 pi, the radius halfway across, radius is 6.5 divided by 2, so that's going to be 3.25 all squared plus 2 pi, again 3.25, and then the height, which is the length along there, 10.3. Now let's stick that, and because we're doing the 2 decimal places, so we can just stick that in our calculator. 2 pi squared 10.3 gives me 97.08. We'll keep that for now. Okay. So we found all the individual bits. So what's our area total? Our area total is equal to 2 pi 1 plus 2 by 2 plus 2. Oh no, there's only one. There's only 1 3. Okay, there's only the one bottom, and then plus the cylinder that we found, which we called AC. Right, it was AC. AC. So we get 2 by 26 plus 2 by 41.2 plus 66.95 plus 97.0865 gives me 298.4365. The 2 decimal places is 298.44, and all those measurements are in meters, so it's meters, and because it's an area, total surface area, our units is meters squared. So that's how we do that problem. Now, if you're watching this video as part of my class in 2020, I said there was a little tidbit of information here to know if you've watched or not. It's my birthday on Friday in class. You're more than welcome to say happy birthday, but don't say it for the first 5 minutes. Leave it for the first 5 minutes so we know who has and hasn't watched this video. So that's that example done. And that was a combination, to clarify, let's go all the way back, sorry, a bit of a rush. To clarify, we used a combination. We used breaking the shapes down, so that's what we did here. That was breaking down. So that part was just definitely method one. We just looked at what are the individual faces. Well, I have the front, I have the sides, I have the bottom, and then this bit here was partly method two. So using the formula, but adjusting. And then I brought it all together to get my area total, which is what I used AT. And you're completely fine to use this 1, the 2, the 3. The other thing you could have done technically is written it as area with a little 1, area with a little 2, area with a little 3, because that's the notation we used back over here. So technically this would be more correct writing because that's the notation we used. But either one's fine. Either one's fine. Rightio. Let's have a look at this one. Find the total surface area of this complex solid. Again, correct to 2 decimal places. Now, on first looking at this, you might be thinking, okay, I need to break down this. I have a front, which we'll call area 1. We have sides, which we'll call area 2. There's also a base in there, okay, which we could call area 3. But then the problem on the top, okay, is that if we look straight down, the top is only this bit around the outside. Okay, so then we might call that, let's call that area 4 as well, but then area 4, we know the sides. What are the sides? The sides are 8 and 8, which we can see there. We would go, okay, that is equal to 8 squared, but then I've got to take away my circle. So that gets really complex. And we start having to add up all these things and breaking it down. You could do, and it would be completely fine, because area 1 is equal to, what's that? That's 8 by 8. Area 2 is equal to, of course, 8 by 8. Area 3 is equal to 8 by 8. And then area 4, take away the circle. And then the circle, what's the circle going to be? That has a radius of 4. So that's equal to pi 4 squared. R squared, yep. So we could do all of that, and that's completely fine. And we're actually most of the way there. But there is one thing we could hopefully notice. This top bit would perfectly fill that hole. So we might call that area circle for the top, which we just said. Over here is pi r squared, which is equal to pi 4 squared. But that would perfectly fill that hole. So instead of going, I need to go A4, take away the circle, but then I'm going to add it in for the top. Let's pretend that that top bit is down there and fills it in. That's all filled in by the circle. So we end up losing nothing. So this whole section at the top, this combo, and I don't want to use AT because we normally use that for total. Let's call it lid, L. So we'll go AL is still equal to just 8 times A. Call this bit AL. So we don't have to use that one, because we've just taken that top bit, the lid, and moved it down, filled into that gap, because the circle perfectly fills in that hole, well, then it just turns it back into a regular rectangle. So we don't need that anymore. So we've got our lid, and then all that leaves us is the wrap bit going around the side. So draw it well enough. Now if I cut that there and expand it out, well, that's just going to turn into a rectangle. So that distance around there is that distance there, which we talked about way back on the very first slide, yeah? The wrap. The width of the wrap is just the circumference. So that would be equal to 2 pi r, and then this height here, which we have is 7, we're told that. So the area of our wrap is equal to 7 times by 2 pi r. So we now have all our parts. We've broken it down, we have all our parts. So our area total is, we have area 1, that was the front, but we also have the back. So we have 2 by area 1 plus 2 by area 2, because we have the two sides, the left and the right. We also have plus, technically, just to be clear for you, we have 1 area 3, which is the bottom in the green, plus the area of the lid, which was this combo bit here. That's our area of the lid. And then plus the wrap. So we can find our area total is equal to 2 by 8 by 8 is 4, plus 2 by 64, plus 64 plus 64, plus the area of the wrap, which is 7 times by 2 pi 4. So we get 64, 1, 2, 3. So all I'm doing is just putting this all in my calculator. Gives me 559.93 once we round. And the units were given in meters, and again, because it's an area, it's a surface area, it needs to be meters squared. And that is the problem done. 60, before I have to run off to meeting. Yes, I've got 7 minutes, so we can cover this last example. Like always, if you have questions, ask in class. Right here, in this exercise, there's some questions though that don't ask you, or ask you to work in a literal form, in that you're only given letters. You aren't told what the radius is. You're told there's a radius, but it's just r. And to build your own formulas. Which isn't that hard. Don't get scared. We can still think of, okay, what are the basics, break it down to the individual shapes, and substitute in our letters. So what do we have here? Well, we have a half circle there and a half circle there, and we know the area of a circle is equal to pi r squared. And I have, to be clear, we have half a circle at the top. Okay, so we have half of the circle at the top, but we have 2 of them, because we have the top and the bottom. So we get 2 times by half of the area of the circle. So the 2 and the half cancel out. And that's pretty logical. We add half the circle of the top with half the circle of the bottom, and we get a full circle. So we get all the red is just that. On the back side, and this is where we just can't halve the cylinder formula, because we actually now have this flat bit on the back. So the flat bit on the back that has a height h, and then this distance across here There, that's an R, and that's an R. So we could say the whole distance is 2R. And we'll call that area rectangle, and that is equal to H times by 2R. And then the last thing we have is the wrap that goes all the way around. So we have our area of our wrap now. Again, it's only half a wrap. So we have half, and then the formula for a wrap was 2 pi RH. So the area of this wrap, because it's half of it, we just get pi RH. And we have, that's the three components. The circle top and bottom, which we've combined. So this is the circle top and bottom. This is the wrap. And this over here was the backside. So our area total was equal to the area of the rectangle, call that B for back. Area of the back plus the area of the circle plus the area of the wrap. So in this case we got H by 2R plus pi R squared plus pi RH. What do we get? We get 2RH plus pi R squared plus pi RH. Can we simplify this at all? Well, we have an RH and an RH. Now, pi looks like a symbol, but pi is just a number. So we've got 2 RHs plus pi RHs. So we could say this is, factorizing this way is much of a muchness, but we could say we have 2 plus pi RH plus pi R squared. And done. That's our formula. We've made our own formula. Now I went through all these examples pretty quickly. It comes with time and experience. You get used to looking at shapes, breaking them down. As soon as you start thinking of total surface area, you're like, oh, I've got half a circle at the top, half a circle at the bottom, I've got this bit going round, I've got the bit on the back side. And it even helps if you have the objects around you. Okay, grab some objects around you, and that helps you visualize the individual components of it, the individual faces. I'll leave it there. I'll see you on class on Friday. If you have any questions, let me know like always. Yeah, thanks and bye.